Hey, what's up, everybody? I love it. We got people in chat. Brr. Is it cold outside? Yeah, it's a new intro. I haven't used that one lately. I should have used it more often. We got so many intros. I've got a whole bunch of ones I rarely use, and that's one of them right there. It has a time for a previous class, so we set that up to be the 5:05 when the class started, and so now it's not evergreen. We can't use it every semester because it's like, wait, why is it go off at 5:05? So yeah, let me re-wake up Newbot here. We have finished the homework. We did all the difficult ones during last office hours. So should we do more of the quiz? Who wants to do more of the quiz? What's up, Jackson? Who wants to do more of the quiz? Not yet. Homework question 8. Let's take a vote. We'll take a vote. If you're here, you get to vote. So we'll start a poll here. Homework 8 or quiz questions. Homework 8 is in the earlier office hours, but if you're here, you get to vote on what we do. So the vote is in the chat. Homework 8 is in the... You've done it 3 times right now. I can't get number 8. You might be doing number 8 here. Take a vote. I'll be getting everything up and going right here as we speak. Shall be choosing things. Win the vote here in 5, 4, 3, 2, 1. Vote ended. Poll ended. Looks like it's homework 8 as far as I saw. Okay, it's 2-1. So you were here and you got to vote on it. Okay, number 8 all boils down to what? This is the man who moves to 2 cities, right? A man who moves to a city and has 2 bike routes. Number 8 is all boiling down to what? What's the deal with number 8? What's the deal with number 8? What is the deal with number 8? All going to be notation. So let's go ahead and take a man who moves to 2 cities and get this going right here. Or a man who moves to a city. A tale of 2 cities. Stat 201, chapter 17 quiz. Man who moves. Notation, brother.
Notation, brother.
Thank you, Leo. All right, let's check it out here over on the main screen. Okay, we got a man moving to 2 cities right here. So let's start by copying the problem and marking all of our notation. Okay, so I need you, as I write this down right here, to start telling me the notation for this. You ready? See in the chat right here if you can help me out with the notation. I'm going to write the equation for you, which is y bar b minus y bar a, and they tell you to do it this way. They say do a b minus a, plus or minus the t star with degrees of freedom, and square root s sub b route squared over n sub b route plus s squared a route over n a route. Okay. And so it looks like Evan's got some means for us. Sample size for both is 20. It might be right there. Great job, Evan. It looks like they write each route 20 times. That's right. And so we have the average for A. And then we have the average for B. See, it says route took on B, average of this. That's the average for B. And the average for A. The average for A. And then we need, no P though. No P though. There's no P for this one. P is for what? Well, you might be saying like a confidence interval percentage, but P is used for what? When we use notation P, P is used for what? So you might say it's a 95% confidence interval. That would be accurate. And good work right there. We got 3 some points for all this. So P, when exactly? Thursday. We'll be doing it Thursday at, I believe, around 3 p.m. The upcoming live stream on the page, but not a time. We'll be doing 201, then 320, then 474, and I'll be announcing in class tomorrow. Thank you so much, Ella, for asking. But we will be reviewing Thursday. It'll be the 3rd review in the series. I'm going to go about 2 hours each. So on study day, I'm going to do a review for each class. So I'll be here on study day doing a review. So now the only thing we are missing right here is the what, which Evan was kind of alluding to because it says making 95% confidence interval. We just now need the what. So we're 1 step away. We are 1 step away from solving this. We need the degree. Ooh, we need some degrees of freedom. How are we going to find that? How are we going to go find those degrees of freedom? Help me out in the chat right here. My last office hours will be Wednesday at this time. So we need the degrees of freedom for the T. Where we go for that? Who knows in the chat? You might, yeah, it might be it. And we have the link right here. If you do TDF, I should make it so that link right there. Yep. And so here it is right here. Thank you so much for dropping in the chat. And so there's the T degrees of freedom calculator. Both of our sample sizes were 20, and then I think it was 5 and 2. Let's double check real quick. Both sample sizes are 20, and then we have 4 and 2. 4 and 2. And since they're both 20, we don't have to worry about mixing them up between the two, like N1, S1, N2, S2. So there are the degrees of freedom. It's about 28. And I'd probably round this in the applet. I think it's best with this applet if you round it. And the degrees of freedom tell us the what of the T. The degrees of freedom tell us the what of the T. I'm going to put 28 right here. It did change it. This one doesn't use decimals, so I would go ahead and round this up. Since it's so close, this one doesn't count decimals, so I would round it up. Not round it up, but round it. So round your T, I would say, in this, because this one doesn't count degrees of freedom. So I would round it because this is so close to 28. I'd go ahead and round it right there. So the degrees of freedom tell you the what of the T. Do you see it changing? The degrees of freedom tell you the what of the T. And as it gets more degrees of freedom, it's more normal. The degrees of freedom tell you the what of the T, the shape of the T. So there's infinite T's based on the degrees of freedom. And the more freedom it has, the more normal it is. Like you get this 1.96 like you would have on the normal curve. And the normal curve does not have degrees of freedom where the T does. And the T curve was invented by William Gossett, who for 10,000 points worked where? Sometimes that question's on the test. William Gossett worked where? Where did William Gossett work? Brewing company, Guinness Beer. William Gossett worked for Guinness Beer. So we have right here the 95% confidence interval value. I'll show it the more traditional way of 95% of the center. So you want to make sure you do the middle. And it does say P right there. So that is the percent shaded in the middle. Evan, I got to throw you some points. I think it was Evan who said that's not technically P, but it is trying to say P value. I wish it said percent confidence. That is a 95% confidence interval. It is saying P right there, but usually think of P as P value. So I see why you said that right there. So that is correct. Paste it from teaching test 3, teaching the test moment. Yeah, that is right there. Let's pin that right there. Good comments right there. Blake worked at Guinness Beer and is creator of the student T distribution. So we know all that right there. Oops, wrong button. And we'll go over here. What was the T statistic again? 2.049. 2.049. So 2.049 square root and 2 over squared. Make sure to square it. 20 plus 4 squared over 20. That's going to be 1, isn't it? Whoa, I think that's 1. And then round B is 53. So is it actually going to be, I think I can do this one in my head. I like doing things in my head if you can't tell. Ooh, is it actually going to be, so try and do it in my head to see if I get it right. Is that right? Wow. Okay. Because interestingly enough, 2 squared is 4 and 4 squared is 16. 4 plus 16 is 20. 20 over 20 square root is that. So that's why I noticed. I got really lucky on the numbers. It turned out really nice. 2 squared is 4. Divided by 20 is that. 4 squared is 16. Divided by 20 is that. They add together to 1. You square root 1, you get 1, and that's the standard error. Then multiplying it by the t-score, we'll get this right here. And that is the margin of error right there. And there's plus or minus this. So this interval could be called plus or minus 3 plus or minus 2.05. And I solved the rest of my head right there. So that is equal to an interval, when you solve it out right here, of 0.95 to 5.05. Does that make sense right here? Sports reporter suggests, yeah, we haven't done that one yet. That's from the quiz. But there is the mathematics on how to solve it. Make sure you know that everything here is the what? Everything I've just highlighted right here is the what of this interval. Everything right there is the what of the interval. Everything right here is the margin of error. That's the margin of error, and then this is the center of the interval. So 3 is the best estimate of the difference, plus or minus 2.05. And you can see it right there as we follow through the mathematics of it, and we achieve the answer. So should they believe the 5-minute claim? Yes or no? So should they believe it, yes or no? That there is a difference of 5 minutes in the route. Should they believe it, yes or no? Should they believe the 5-minute? Yes, they should believe it. Why? They should believe it. Why? Don't even read their answer. Just think about they should believe 5 minutes. Yes, because why? Well, do you think I am 95% confident the true difference in this route is somewhere between 0.95 minutes to 5.05 minutes? So I am 95% confident the true difference between these routes is somewhere contained in the interval 0.95 to 5.05 minutes. So I should believe 5 minutes is possible, not because it's more than 0.05. I should believe 5 minutes is possible because why? What do you notice about the interval? Why would I believe 5 minutes is possible? I would believe 5 minutes is possible because 5 minutes is contained in the interval. So we would think 5 minutes is a possible value of the truth because 5 minutes is contained in the interval. And does that make sense right there? 5 minutes is a possible value of the truth because 5 minutes is contained in the interval, to say like, well, the difference is probably somewhere between about 0.95 to 5.05 minutes. So yeah, I believe 5 minutes. I don't reject that. That seems possible to me. So very important. Good question right there. And we have all the other ones. If you're looking for the tough ones here, which are at the end, we did all the tough ones here at the morning. So check those out. Really good review of notation. And then we have the sports reporter one right here. Sports reporter suggests. Let's go grab that one from the quiz. I forgot which one. Okay, let's go grab it from the quiz. Do as many as we can right here. It's funny, I hear this in like YouTube videos, and I'm like, that's my song. I mean, it's anyone's song who wants to use it. Okay, a sports chill music. We love some chill music. Wait. Wait. What's this case for? I think this is. How many parts does your question have, Blake? How many parts does your question have? Because I found one of those with one. But I think I found it right here. I think I found it. It's got multiple parts. Because I remember there's apparently new. It only has one part. Evan, you might be looking at the short version. I think Blake's has multiple parts here. So let me know, Blake. We'll do mine. Yours just one. We could do that one too here. We'll maybe do both of these. I saw 2 versions of this, but I was like, did they change it this semester? Blake, where you at? Blake. Oh, here we go. Let's check it out. All right, here we go. A sports reporter suggests that professional baseball players must be, on average, older than professional football players for reasons. Since football is a contact sport, sure. Researchers select 29 and 27. Those are the sample sizes. And what does Y bar represent right here? What does Y bar represent? This is the what of what. This is the what of what for the 27 and 29 respectively. Oh, we'll do it here next, Devin. Not sample proportion, though. Not sample proportion. Not sample proportion. Good answers, Evan. Good practice. Not sample proportion, though. Not sample proportion. Those are the whats. Throw you some points here for that. Sample mean, because it's quantitative, right? No, this is the practice. Don't worry. We've done proportion stuff. Mr. T will use the T distribution here, and you see mu for the true mean. So this is the practice to be like, oh, yeah, it's sample mean because we're doing quantitative. So that's what we're doing right here. We're doing some mean stuff with quantitatives. The data collected are summarized to show the researcher decides to test. The degrees of freedom are this. So they give you the degrees of freedom here. We like that right here. If we wanted to get the degrees of freedom, we'd put it into the 2 sample T degrees of freedom. listed below. We don't have to do that because they've already told us. The 2 sample t degrees of freedom formula is a too complicated formula which we do not solve for on the test. So what would the null hypothesis have? The null always has the what? The null always has the what? So we can eliminate one of these, A, B, C, or D, because the null has the what? The null has the what? The null has the equal sign. So with the null having the equal sign, we've eliminated answer D. So let's look right here. We want to see if there's a difference and one mean is higher than the other. So we want to see if baseball players are older than football players, and baseball players is mean 1. So which of these A, B, C are the ones we should be considering right now? Because we're looking for a one-sided difference to say baseball players are older than football players. Which of these can we look at now? A, B, or C? Would you be between which answers here? And I'll show you how to pick between them. Would you be between A, B, C? What would you be between here? Because we're looking for which the baseball players are older. So baseball players are older. Well, C is looking if there is a difference. So C is the one we can eliminate. So C is the only one now we can eliminate because we're looking to, this would say, is there a difference? And it might be A. Let's take a look. I think it is A, and here's how we can figure this out. So when you look at the alternative right here, I'll zoom in on it. Remember that the first mean is baseball, and the second mean is football. And you can take this symbol right here and plug it between them, and this would be baseball is what to football. If you put that symbol between them, that is to look for evidence what. So you can just take that symbol and plug it right there to test mu baseball, and that would what? So you can just plug the symbol between them right there to see what. That's a quick way to check and to see baseball players are older than football players on average. Like if we have evidence that the average baseball player is older than the average football player, and that's what we have with the true mean for baseball players is higher than the true mean for football players. So the answer is A, what we're looking for right there. It's the one-sided test. So now it asks us to compute the t statistic. So this is all going to boil down to what here? Every bit of this now is going to boil down to knowing our what. This whole question now is simply knowing the what. So it's baseball minus notation, brother.
Notation, brother.
So we have y bar baseball minus y bar football. Make sure they did football, baseball minus football. Make sure you do it in that order. Square root, and this is the standard error right here. So we need to standardize this difference. There's the standard deviation of baseball over the sample size of baseball plus the standard deviation of football squared over the sample size of football. And so we're going to write this below it. That is equal to a t with the degrees of freedom they stated. Okay, so this is to get the t statistic, and we have 27.56 minus 26. Oh my gosh, that's the worst 2 I've ever written. I was actually looking at the homework. This question is... Oh, wait. It is on the homework? We can do the homework version of this next. Okay, so there's the T. This is the harder version. Yeah. Whatever you want to do next, Evan, let us know. This is the harder version of it. Oh, why did I square? That should not be squared on the bottom. Don't square that. There's no squaring of that. Divide by 27. I think I did that right. A little worried. 3.92 squared. Divide by 27. 2.84 squared. Divide by 29. Plus those. Square root. I have just now found the what of the difference. I have just now found the what of the difference. This bottom portion is known as the what of the difference. That bottom portion right there is known as the what of the difference. The bottom portion is the standard error of the difference. So I just found that quantity right here, and then I'm going to take the difference up top and divide it by the standard error of the difference. So let's go ahead, 0.92. And now we go right here, and we take 27.56. Oh my gosh. 27.56 minus 26.51. There we go. And that was, so it's 1.14. And the top number was 1.05. So that is the T statistic right there, 1.14. 1.14. So now from the T statistic, we find the what? 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 Next step right here. Well, we know the degrees of freedom, and we'll use the degrees of freedom to go to the applet and find the p-value, and it's probably something about this right here. So let's go ahead and take the T statistic. Let's go over to our T. No, it's good practice. From the T, we find the p-value, but you do need to know the degrees of freedom for the T, and it's 47 degrees of freedom. This doesn't carry through the decimals. 47 degrees of freedom. We put in the T statistic right here, and will I do 2 right or left? 2 right or left? Which of these will I pick? Will I pick 2 tails, right-tailed, or left-tailed? Which of these will I pick? 2-tail, right-tail, or left-tail? Which of these do I pick? 2-tail, right-tail, or left-tail? 2-tail, right-tail, or left-tail? Which of these do I pick? Which of these will I pick right here? The right tail. If you're wondering why we picked the right tail, it's because of the sign of the alternative. The sign of the alternative points to the right, so when you have an alternative that points to the right, you'd go to where you land on the T distribution and shade to the right of it. Notice how this points to the right, so you will shade to the right of it for the greater than test. Great work and good practice. The sign of the alternative determines which way we shade. That might have been close enough right there. I think this does carry 3 decimals. I'm going to see if I got it right by guessing it. I always like guessing those. So at the 0.01 alpha level, would you reject? Because I'm right-handed. Would you reject or fail to reject? Reject or fail to reject at the 0.01 alpha level. Reject or fail to reject with this p-value. At the 0.01 alpha level, reject or fail to reject, which means, yeah, it says fail to. Sometimes it says not reject, which I say. We would fail to reject. So does that mean there is evidence for the alternative or there is not evidence? So if you fail to reject the null, would that mean you do have evidence for the alternative or you do not have evidence for the alternative? So if we fail to reject, there is evidence for the alternative. If there, we're between 2 answers. So wait, think about this. If you're rejecting the null, it would be because why? So finish this sentence. I'd reject the null because I have what for what? I would reject the null if I had what for what? So finish this sentence. I would reject the null if I had what for what? Like, be like, I would reject the null if I had this for this. I would reject my null if I had this for this. Evidence for the alternative. And so if we don't reject the null, it's because we what for the alternative? So if we don't reject the null, it's because we don't what for the alternative. So like repeating this hopefully helps to be like, oh, if I had evidence for the alternative, I would reject my null. But if I don't have evidence for the alternative, I would not reject the null. So I failed to reject the null because there's not enough evidence for the alternative. My guess wasn't close enough, it looks like. So there we go. The guess wasn't close enough. How far was I off on it? Was I just like a 10,000ths off? Really? I was 2 10,000ths off on my guess. I'll do better next time, but my guess was 2 10,000ths off. I was hoping I could guess it, but 2 10,000ths. Pearson being petty right there. I would probably give it. Don't try to guess it like I did it. You should go to the applets. If you've done these enough, you kind of know what the p-value should be close to because T's become closer to Z's with more degrees of freedom. So I actually used a Z-score that I kind of knew. Do we use the degrees of freedom for this problem? We didn't have to because it was already given to us. It already gave us the degrees of freedom. Had this problem not giving us the degrees of freedom, which are 47.16, we would have to take this information right here and go over to the TDF right here. So you could practice doing this right here to understand that if the problem didn't give it to you, you would go here and put both sample size, 27 and 29 respectively, and then your standard deviations are 3.92 and 2.84, and there's the 47.16. and the 47.16 is right there. So does that make sense right there? It's the degrees of freedom formula is a complicated one, which we do not solve by hand. So a lot of times problem will give you these answers right here. So you could have found it if you wanted to, which is good understanding to know that this applet right here, and I'll show the formula again. The degrees of freedom formula, if you are wondering, is a very complicated formula, which we will never solve by hand. Copy image address. It's the following formula, which we do not solve by hand. So this right here is the complicated formula. What other questions should we do right now? We've done a lot of good ones. Let's head back to the main screen. Should we do the other one? The quick one? There's a quick one of this. Should we just do that? I only have the multiple. Yeah, let's do the quick one, right? Let's do the quick one. Let's do the quick version. And so we'll do the version 2 of it, the quick version. All right, let's do the quick version. Drop other questions. You got them in the chat. Okay, so let's hop back over here to the quick version sports reporter problem. Here we go. Okay, we're going to do the quick version of the sports reporter problem. Here it is right here, the sports reporter 1. How do you feel about the bowl game? Which one is it? What bowl game are we in? I didn't know that. A sports reporter suggests that professional baseball players must be on average older than professional football players, since the football player is a contact sport. One player was selected at random from each team. The data are summarized in an accompanying table. The sports reporter calculated the 95% confidence interval, and here we go. It's baseball minus football has this interval. So right here, Clemson. Oh, we're gonna do awesome. So tell me what this interval means. You are trying to figure out the what between the whats. Tell me about this interval. This is a really good question to go a little in depth on. We are trying to figure out the true what. Oh, that's all right. We're trying to figure out the what right here. The true mean? Well, we have two samples, right? We're trying to figure out the what between the two means. You're on the right track. Well, proportions is for categorical. Sorry, Evan. Proportions is categorical. So we're not going to deal with proportions right now. This chapter is all about the whats. This chapter is all about the whats. We're trying to figure out the what right here. Well, something with the mean. We are trying to figure out what? The true difference between two means. So the true means, right? So we're trying to say, is it true that on average football players or baseball players are older than football players? What was, and you can do it to one decimal, what was the sample difference? What was the sample difference? These are all just in-depth questions. What was the sample difference? And you can tell me to one decimal. What was the sample difference? This is some really good knowledge to understand you understand how to read this. Go ahead. Was the sample difference 1? Well, that's the difference in sample sizes. They sampled 31 baseball players and 32 football players. So they talked to 31 baseball players, 32 football players. And then what was the sample difference? So see if you can find that here. So find me the sample difference. Not 1.12. That's the difference between standard deviations, I think. So what is the equation for sample difference? The equation for sample difference would be y bar baseball minus y bar football. That's the equation for sample difference. So the difference between the two means is the difference of what? How would you interpret that? So how would you interpret that? That baseball players are what? So interpret that difference right there and just look at it and think about what it means. Like the more you understand these problems in the context of them, the better we can do at interpreting and knowing how to use this. In our sample, we saw what? In our sample, the sample showed that baseball players, and this is from a sample, that baseball players were 3.83 years older than football players on average. Does that make sense? In our sample, we observed this difference. So now when we think about this right here, the confidence interval is completely positive. Do you see the confidence interval right here? Because it's baseball minus football. So think about this. This means that we are 95% confident that the average baseball player is somewhere what to what than the average football player. I am 95% confident the true difference between mean ages of baseball players to football players is contained in the interval. So what does this mean? Try to think what that interval means. Like, we're trying to be like, well, on average, what? We are 95% confident that on average, baseball players are somewhere between 2.1 to 5.56 years older than football players. I am 95% confident that the true difference between baseball players and football players' ages is contained in the interval 2.1 to 5.56. And it might be. Let's see what it says right here. We are 95% no. This is dealing with a sample. So this is no. Because we are not concerned with the sample, we are concerned with an interval of talking about the what. That talks about a sample right there, and a confidence interval is not about a sample. A confidence interval is about the what difference, not about what we would see in a sample. The confidence interval is trying to estimate the what difference between the means. The confidence interval is trying to estimate the what, the true difference. Let's see what this one says. We are 95% confident that the mean age of baseball players is between 2.5. That sounds right. And not a 95% chance that it contains the truth. It's no, the interval is 95% confident. No. I am 95% confident that the true difference between the ages of football players and baseball players is contained in the interval blank to blank. Exactly. So if you look at how it works, but this mentions samples, no, confidence intervals are about the truth. Pretty good question right there. And last question I'll ask for 10,000 points. What is the margin of error of that interval? What is the margin of error? And I'm calculating in my head. I have a guess of the margin of error. And if there's a plus or minus 0.1, I would have it correct. What is the margin of error of that interval? Actually, now I know it down to the decimal by looking at that over there. What is the margin of error of that interval? I'm going to write it down here on the screen real quick so you can't see it, and I'll pull it back up. But if you know how to get these values, you can get them pretty quickly. Not quite. Good. Let me see how you got that. Oops, that's not the right screen. I wrote it down on another screen so you know I'm not cheating. So what is the margin of error of that interval, and how would you find that? So how do we find margin of error of an interval? Yep, there's numbers over there. How do you get the margin of error? How do you get the margin of error of an interval? What is one way to get the margin of error? Good review. We love reviewing theory questions on how to get things like this and understand that the margin of error is half the length of the interval. The margin of error is half the length of the interval. And I also cheated because earlier you told me that the difference was 3.83. And the lower is 2.10. And the upper of this interval is, and I can find it mathematically here. Oh, there it is. 5.63. No, 5.66? Let me double check. Oops, wrong one. 5.56. Oh my gosh, I can't do math. So, do you know how I solved this? So, one way to get this, show the mathematics in the chat for anyone watching this in the future, trying to learn of how to do the margin of error. So this is the margin of error highlighted right here, which is 1.73. So how do you get this margin of error right here, this plus or minus? So show the mathematics. We'll do that one next right here, the Core Plus Mathematics Project. We'll do that one next. How do you get this margin of error? How do you get that? The formula is, well, that you're on the right track, Blake. So upper minus lower divide by 2. So we need the difference divided by 2. But also, do you know how I got the margin of error? For 10,000 points, how did I solve the margin of error? How did I do it in my head? I'm circling something to show you how I got it. Oh, Blake's showing it right there too. Blake or Evan actually showed it. Blake or Evan did it a different way. I did it with those numbers right there. Does that make sense, Evan, how I did it? Is when you told me the difference, which is the center of the interval, because the interval is the difference plus or minus the margin of error. Well, the difference is at the center of the interval. So I just subtracted that and I was like, oh, 1.73. So that's how I found it in my head. If you're wondering how I got it so quickly, I didn't I didn't take the difference and divide by 2. And sorry, Evan, I got to throw you 10,000 points for correcting me right there. What you did, which is a correct way of doing it also, is you found the difference between these because that's half the length of the interval, the upper minus the center of the interval. So really great work right there. And just seeing things like this, because there's lots of ways we can ask it that requires the theory. Whenever there's a chance, yeah, what do you want to know, Katie? Can we do what do you want to know on 474? I can't do too much for the project, but I can answer general questions, but I can't do too much. But what are you wondering about 474? Let me know in the chat, and we'll take a look. Let's head back over here. Accounting coming up. Do we have time? What are you wondering about 474? Drop it in the chat right here, and we'll see what we can do. I'll see what I can mention. I can't go too much detail on it. 474, big project. Can't go too much in detail. But what are you wondering? What are you wondering? What questions? Drop those questions about 474 in the chat. And what are you wondering? Let's take a look here. The concepts for proposed levels. Yeah, let's look at some proposed levels. We'll do the proposed levels function. Let me write that down here next. Proposed levels function. So proposed levels. We'll look over some proposed levels with BAS 474. Thank you so much. BAS 474. Propose levels function. I need to get rid of the missingness ourselves, and need to. Well, yeah, there is, I think, included in your code the complete cases, which complete cases gets rid of missingness. So it all depends. It all depends on how you want to handle it. So dealing with missingness is a bit of a fun part of the problem. Let's see right here. I gotta find that one for to say. The question is it at 4? Something big at 4? Oh my gosh. I gotta get my other keyboard. This keyboard is breaking. There's a key that breaks off here every once in a while. The Core Plus Mathematics. Is that chapter 17? Found it. Found it. And this is a what problem right here. The Core Plus Mathematics is a what problem. The Core Plus Mathematics, if you're seeing it right now, is a what problem. It's a know your what problem. What are we going to be doing instantaneously for this right here? With this right here, the Core Plus Mathematics problem is a know your what problem. The Core Plus Mathematics problem is a know your what problem. You have to know your what's for these problems. What do we have to know for these problems? This all comes down to knowing your notation. So it's asking right here, first off, let's see, after field test 36 high schools over a 3-year period, researchers compare the performance of these students taught in one test students how to solve world problems, the other traditional what do you conclude. Are they looking to see if there's a difference? Project is an innovating approach to teaching mathematics that engages students in group investigations and mathematical modeling. After field testings, are they looking, this is a new one this semester. They want to know the null first. This is actually huge for this problem. Do you see that they're testing the new way is better? The Core Plus Mathematics project is an innovative approach to teaching mathematics. So I think they're trying to show that it's better. And so if we were to show that the Core Plus Mathematics approach is better, which of these alternatives should we use? This is actually very important. Should we use A, B, C, or D? I think they're implying that they want to show it's better. This table shows what you conclude. It could be not equals to. It might be this. I'm a little worried. We'll find the answer to this. If they want to show better, here, we'll cheat really quick. You ready? He's going to show me it. No, they're doing not equals to. They don't mention the sidedness of it. So you're just seeing if there is a difference. So I was a little worried with the way they're wording this. I should have went, because you're just seeing if there's a difference. That's why I wanted to click it to find out, because I'm like, they don't mention that they're trying to see which one is better. Yeah, they're just, if it doesn't tell you which way it goes, you have to assume they're just looking for a difference. I wish they said, is there a difference between the teaching methods? The test should be more specific. We always try to make it as specific as possible. The question would read, is there a difference between the teaching methods, which is the alternative hypothesis of the not equal to 0. So that should be more specific in this problem in my mind. I was like, I don't want to do the whole problem, then someone rewatch this and we find out we were wrong on one part, because if someone's following along, I want to make sure they get the right answer. The question is not asking, is the Core Plus mathematics project a better way of teaching? It's saying, is there a difference between these two methods? So very important to know what alternative they're doing, and I wish they were more specific right there. So now it really comes down to, let's make sure we have the same notation. I'm going to recopy, repaste just in case. We have all the notation right here, and we have to find the t statistic. So they are doing first Core Plus mathematics. The Core Plus is the first one. Okay. So the Core Plus is the first mean. And so let's write down the notation right here. So y bar Core Plus minus y bar traditional over square root sample size Core Plus squared over, or standard deviation Core Plus, and Core Plus plus standard deviation of traditional over sample size traditional. Okay. So now let's go right here and do the Core Plus, do the bottom of it. So the standard deviation is 32.07 squared divided by 320. And we're going to copy that. Traditional 28.47 squared divided by 273. Add those up, divide by 2, 2.4 or something. There we go, 2.48. And this might be something. It's going to be close. It's going to be a close call. And the difference up top is the difference of 3.46, I think. Double check that. It's going to be an interesting number. So 50, yes, 57.39 minus 53.93. There it is right there. Divide by 1.3914. 1.3914. There we go. That is the t statistic, which is what we have been trying to find this whole time. The whole thing right there is the t. 1.3914. That is the t. From the t, we find the what? From the t, we find the what? From the t, we find the what? Once you find the t, you go and find the what now. From the t, you find the what? From the t, you find the what? From the t, you'll find the what? The p-value. And this p-value is going to be somewhere in the neighborhood of, this is a close guess of it. It falls off quickly. It's going to be somewhere like that. Let's go ahead and take a look over here, and it does give us the degrees of freedom. 590 are the degrees of freedom. So we do not have to find the degrees of freedom ourselves. So we're going to go over here and go to the t-applet. And on the t-applet, we'll enter in 590 degrees of freedom. And then will we do the two right or left tail, Blake? Or Evan, I think Evan was talking right there. Will we do the two right or left tail? The two right or left tail. Which of these will we use? The two right or left tail? The two-tailed, because the alternative was the does not equals alternative. Since we are using the does not equals alternative, we are doing the two-tailed right here. And then I was close with my guess, but not close enough. The p-value is 0.164. So close, but no cigar. Now, would we reject the null or fail to reject the null at the 0.10 alpha level? So remember, when the p-value is high, just let the null fly. When the p-value is low, reject the null. How do you know the p-value is low? It's lower than alpha. Alpha is the bar by which you reject. So since the p-value is high, we fail to reject the null. If we fail to reject the null, it's because there is evidence for the alternative or there is not evidence for the alternative. Or we say sufficient, there's not enough. So would we reject or fail to reject? We would fail to reject, and there's not evidence. There is not a sufficient evidence for the alternative. So let's check the answers right here. Yay! Good question. There's not enough evidence for the alternative. Well, that's got it right here. We can do more of these coming up. I think we're going to do a little 474. But check it out if you're watching this video right here. We've done we've done all the quiz today. We've done the homework today. We probably need to put this to homework. Updating these notes right here for people's future reference. End of semester, busy time. There we go right there. And let's go check out some 474 right here with proposed levels. Let's do it. Okay, some proposed levels. Let's do it. Pull up the using carrot file here. Woohoo! Okay, let's go check out proposed levels. And I think it's in the using carrot, right? Using carrot. Here we go. You're welcome. Great job, Evan. Oh my gosh, I can't spell proposed levels. There it is, proposed levels. Boop. Okay. So with proposed levels right here, I'm going to take and copy this function. Wow, that's a function and a half. What's going on with that? Levels. One thing you can do with RMDs, I'll show you this right here. File. I'm going to make a new markdown file and go random work 22. Okay, there we go, random work 22. We're gonna go here to this chunk and we're gonna call it proposed levels function. So you can go here and you can go to on your chunk, you want to go to show nothing but run code. So it's going to run the code but not show anything when it runs it. And then you can drop all that in here. And with all of that dropped in, you can then go here and close the chunk. So this is a helpful way. You're welcome, Evan, right there. This is a helpful way right here to deal with very large things like this right here. Unpin message. There we go. Does that all make sense right here? So if you're making your own file, you can just close off a chunk. Yeah, it looks really nice. And then you can just have the function right here. And we should be able to go right here and run the chunk. And then when we run the chunk, we get the proposed levels function. So proposed levels, do I have the notes open for it? I think I do. Smoothing, it's in the smoothing one. Okay. So with proposing levels right here, proposed levels, some good and some bad to it. Like when you think about how to use it, there's a lot of different ways you could use it. Basically, you could take a Y variable of interest, like whether or not someone clicks through, which I think is one of the examples over here. Let's go to the click through one. And you've got different devices. Where's the devices click through? I like that example. Here it is, right? That's not it. There it is. There it is. Here's the devices click through. So you've got different devices, and some of these devices have low frequencies. So you see right here, like D9 has 273 frequency. That's not really low, but maybe we want to make new levels here that are based on this Y variable of interest. So if we look at the code right here, we're basically going to take it and work with it. And let's take right here and go and work with this. So, and what you have to watch out for. So a lot of people are using this for cities. Let's say right here. Let's go to data. I don't know if I have. Let me get a data set with a lot of levels. I think this data set has a lot of levels for some of these. Water habit doesn't have a lot. Okay, it's the Stat201 data set. I'm going to load up a data set here with a lot of levels. That's what I'm trying to find right now. And let me exit out of jump. No, it's going to get mad at me if I do that. Well, okay, we're going to load up a data set in jump that has a lot of levels. Okay, I think this one has it. Let's see it here in a second. Oh, it doesn't have it. I'm trying to find a data set that oh, it's decision tree data. Here it is. Decision tree data has it. Okay, so this data set right here. Do you see a variable currently that has a lot of levels to it? Do you see a variable? Did we eliminate those? Or did I delete them? Oh my gosh, I can't find a data set with a lot of levels. I'm trying to find one that's not your data set. Trying to find a data set with a lot of levels. Decision trees students. Let me see before. Let's try right here. Yes, 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 yes. Okay. Do you see? Don't worry. Do you see a variable with a lot of levels right here? I love it. Finally. Finally. Q15. There we go. Okay, so now we get the fun of bringing this over to Jump. So I'm going to export this data set right here. File, export as a CSV. I'm doing this in background because it's going to save to my computer. I'm going to store it as an Excel file, XLSX. And next, and there we go. And let me call it new data S22, or let's just call it S22 data. And there it is going to my downloads, S22 data. And let's go back over here. It should be saved and it might be opening Excel. It is opening. Okay. So we have it right here. We're gonna load in the data, and let's remove a bunch of this. Okay, so library, read Excel. Why am I loading read Excel up? Why am I loading read Excel? S22 data. Good. Why am I doing this? No. Might come in just fine. Why did I load that? So you can read in Excel files. Exactly. Let's go here to data, store this right here. There's the data. Take a look, and we look pretty good. And one thing we probably want to do, I think this also has it. Really? Really? Let me look at the read Excel function really quick. No, I don't want to do the full thing. I just want to look at the read Excel. Okay, let me look at this. Call types. Call types. I wanted to do the call types. I might just save it as a CSV then and do strings as factors. I don't want to have it guess everything. Ugh. S22 data. Well, you know what I'm going to do? I'm going to save it as a CSV and then read it in as CSV with strings as factors. Save as CSV. It's going to be quicker to do that than typing in all the column types. There we go. S22 data CSV. It is now saved. Oh, it didn't give me the thing saying you're saving as a type. Oh, didn't get mad. Like some features will not be open to you to use. So now let's go read.csv, S22 data CSV, and then do strings as factors true. And now we have it, I think. Okay. Okay, so now we have the strings as factors. The variable names are pretty wacky. I'm not going to really worry about cleaning these up. If I was working with this data more in depth, I'd really be cleaning up these variables, maybe even retype all the variable names, because variable names are pretty wacky right now, but it's totally fine. So we have what we want right now where we can use the proposed levels function. And that's kind of been the goal right here, is to take a code like this and to utilize it to do proposed levels. So let's go right here and grab the proposed levels function and see what we get. Now these are the proposed levels. So if you take a look at the code right here, within the function, it's going to use a tree-based model with a target of 4 levels, and we need to give it our data set. Now, the first thing you're going to give it right here is going to be the X categorical variable you want to use to propose levels for. So this is where it gets pretty fun and interesting with the variable names, and I'm going to cheat by going here and going to attach data. Now, this is something Dr. Petrie frowns against. It attaches the vectors to the global environment. It also needs to be in quotes, so after we type this out right here, which is Q15 major, we need to then take Q15 major and put it in quotes, which it did. Really? What? Maybe R is getting even smarter. Well, target is going to be how many levels we are getting on purpose. So I don't know if R is getting smarter or what, but it did it right there. And the click is whether or not they clicked. This is actually a categorical variable right here. Let me look at the data again before I run it. Device model. So that is based on a proportion. Can I input the quantitative variable there? Like if I want to group these together by a quantitative variable, like, what'll be a good quantitative variable? Let me see if it runs with this. Well, I could group it together on another variable. This is going to put like-minded levels together. We'll go for 15 new levels. And let's group them together on what would be the data we are putting in. Well, this is the variable right here that you want to propose levels for. And then we need something to group it by. So we could do a lot of interesting stuff right here. So yeah, how many it should be. It should be. I'm trying to think of a good variable just to group these by. Let's group by economic views. Social views. Okay. And error. We like errors. Error. Tree target. Is it mad about the number of target levels? Let's reround again. It's super mad. It's saying the complexity parameter of the tree. Oh, it's mad about it. Something mad. Dr. Petrie, what's going on with your code? Oh, it's super mad. Let's do this. When something doesn't run, you always want to run the code it came with to make sure everything's running properly. So we're going to literally take the code it came with here, and there's that. And there's those. And then we're going to take the code it came with and run this just to ensure everything's running in the basic mode. Always run your examples. This is just a mosaic plot in general. Zoom out there a bit. And here's the mosaic plot. I don't usually use that base mosaic. Now you see, now we're getting a problem here, which that scares me. So what does it say? Error in mosaic, unused argument inside. Well, so the inside doesn't like and equals true. So it's mad about all this. Just remove that. And it's saying there's null, which means things don't exist. That exists. And those exist. So why is it mad right there? Error in match directions arg must be a null, a character vector. Why is it mad? Let me change it to the way I usually write it. Mosaic. I don't usually use the mosaic function. Let me look at this real quick. I usually use like GG mosaics. I'll have to show Petrie that it doesn't like from reg class. So there is the formula from reg class. So Petrie's thing should work over here. I'll have to tell him it's not working. We're going to figure it out. See, that's a problem. This is bad. Unused arguments, data equals. So, we need Shreya right here. Because I would bet good money, and I'm hoping this is the issue. Does anyone know what the issue is right now? I was right. Shreya would know it too if she was here. Does anyone know what the issue is? This is an odd issue. And it's not the direction. What it is this function Petrie has right here is a reg class function. So what we need is library reg class, and library reg class should have inside of it mosaic, but the problem is also mosaic is where. So this is what's called masking. And so that's why I was hitting all these issues right here. We'll see what other issues are occurring, but this issue I had right here is because two libraries have the same function. Does that make sense? So now I have to call the function with this, or next time not attach GG mosaic. So the library GG mosaic is running, so it's saying, oh, mosaic function is from GG mosaic. So that has a totally different format to it. So what we want to do right here is go way, way back in time. And there's the mosaic. Or let's change it back to the way it was when we wanted it to work. That's and there it is right there. And now we need to add before it reg class. And there it is right there. So little things like that can throw you for a loop, because I was like, well, we're doing everything the way the function says it should run. And then when I look at the function, it has a totally different setup. So I'm like, I'm not using that same function. Like, unless Petrie dramatically, so Petrie is doing things correctly right here. And these are all the levels of devices right here with the frequencies and the click-through rates. So now we have the proposed levels right here. And let's see if it works right here. But one of the problems we might be running into is I think it's trying to use a wrong function within there. So this is the issue right here. So what I'm going to do is I'm actually going to save this work. I think I know the problem now. New work. And we are going to close out of R and don't save. And now we're going to go back into R because I'm pretty certain the issue is one of the functions in Petrie's proposed levels is probably the mosaic or something like that. And maybe it was, I bet you it's an issue with a package I've loaded up. I think that's the issue. And so let's go here and run it. Let's run Petrie's work right here. EX6 click not found. Oh, we need to go library reg class. Okay, there we go. There we go. Look at this. Now we got it. Okay, good. Okay, so now, well, so in short, is there a problem with my code right now? Is there a problem? Even though it's giving we're missing a comma it's mad about. Argument data is missing. Okay, I can fix that. Is there a problem with my code? Is there a problem with my code? Is there a problem with the code? And then we'll do the arguments here again. But is there a problem with this code right here? Is there a problem with this code? Yes or no? So hopefully this will clarify everything. Is there any problems with this code? No. What was the problem I was running into? Which I didn't expect to hit that problem, but what was the problem I was running into? So to review, the problem I was running into is that some of my packages were what? So there was libraries that were conflicting with things that they were using. So when these functions were trying to run, they were pulling from the wrong libraries. So how did I fix that issue that I had too many libraries running? How did I fix the issue that I had too many libraries running from having R open and running different libraries, and then my R has a whole bunch of different functions to use that I'm not really supposed to be using right now? How did I fix my issue of having too many libraries? Well, I did that, but actually right now I don't need to do that. Now I can go right here and do this, and it works. So I can do that to call from a specific library. And great job, Katie, right there. Let's throw some points. I can do that, but also I did what to fix the issue because I really had a lot of stuff running that I shouldn't have had running anymore. So I also did what to fix the issue of too much stuff running in the background, like too many libraries open. I closed R. I reset R, and that was really the big fix right there. That got everything restarted, restart the whole dang thing. Say, okay, let's shut down all those libraries that are running. Let's restart R and only get the things running that we want running. So now that we have this running properly, because I was like, something's weird. If things aren't working, I always go to the examples. I was like, this should be working. Now that we have this working, we can do it for our data, and cross your fingers, it should work. So here's back to where we were at the very beginning, and look, it actually works. We're going to run the exact same code inside of here, and let's take a look at what we have and see what we got. Okay, so now we're going to do not click. We want to do major. So there we go. Oh my gosh, this keyboard is horrible. So the X variable of interest is the one we created. There's click inside true, and data equals data. There we go, right there, the mosaic. Oh my gosh, woo, that is so cool. There's so many. Wow, this is the coolest plot ever. Okay. What does the target 20 mean? What does the target 20 mean? I know, right? What does the target 20 mean? What does the target 20 mean? You want 20 levels. What does the tree method mean? The tree method means it's going to use a decision tree to try to get these groups as what as possible. When you use decision trees, you want what in your leaves. Think of each of these as a leaf right here. You really want what in each of your leaves. You would love like a leaf like new 7 right here, or new 16. Wow. Why is new 16 so good? Why is new 16 so good? Why do we like new 16 so much? The method is the method by which it's creating the new groups right here. Not super important because there's different ones, but we'll use the tree based method if you want. You could try different ones. It's all up to your choice on what method you want to suggest to propose new levels. And so we're basing it, we are picking new levels for major based on people's social political views. We're picking new levels for major based on people's social political views, trying to group people together right here. And this is all one major. Now, this one has a lot of different majors right here, a lot of different majors right here. So the proportion of majors is all spread out on new one right here. How would we pick what method to use? Give it a shot, whatever you want. There's different ways. Here, let's go look at the proposed levels function. So the different ways in the proposed levels, I think it's in the notation over here. Proposed levels. A little back further. Here it is right here. Method interval, the range of the average y value for p is the same to b. So it's trying to do it on a range, getting things to be the same. Method frequency, the number of individuals in each level should be about the same. So you want to have the same frequency. So each level is going to have about the same amount of groups in it. Method cluster, K means clustering on the average proportion of each level. So you're trying to get things the most similar based on a set of X quantitative variables to get things to have the most similar cluster centers. And the tree-based method was the one we use. The new levels are the leaves of a partition modeling predicting Y from the levels of another X. So these are the different methods right here that you can use. We might try using range of average Y of P for each levels to be the same. Because, well, we don't want that because that's a quantitative. We don't want frequency. I could try cluster. I'd go cluster or tree. What error are you getting when you do proposed levels? So theoretically, if you're doing this city, you would want to choose new levels based on some other. Because we have to have some way to propose the levels, and looking at your other variables, maybe putting things together based on other variables. Command not found. Proposed command not found. It might be. You might have to send it to me. I'm trying to think why you'd get that error. Does it work with the example code? Does it work with the example code? One thing to do, and I do want to put this out there. One thing to do is just not deal with what, which is you might want to use it. One thing to do though, if you're having problems with this variable, is to just what? One thing to do if you're having problems with this variable, which I would suggest using it, but one thing to do if you're having problems with this variable is to what? If this variable is causing you a lot of problem, don't use the variable. That's, we'd like to use the variables. And so you want to get the variable in some sort of way you can use it. But let's say you're spending hours and hours and hours and hours and hours. Because I can't do it exactly. I can't solve this for everybody. But let's say like the answer to solving it. Because put it this way, if you have right here the new levels of X, what could you do with these new levels? What could you do with these new levels? And let's go here and look at a sorted table. So if I split that up, I should get some in the holdout in the train. So what could you do with this new variable right here? What could you do with this new variable? So yeah, that's an restart R. Definitely restart R now, because it seems like some package might be causing an issue. What can you do with this new variable here? What could you do with this new variable to like somehow get it to be part of your model stuff? Because we've created a new variable right here. There's the new variable. So what could I do with that? I'm actually very interested. What could we do with it? What would you do if you create a new variable? Really good question. If you create a new variable, what should you do with it? Maybe send me your code. Maybe send me your code. Send me your code, Katie. I'll take a look. Because if the restart doesn't work and all the functions are running, if you create a new variable, what should you do with it? What should we do if we create a new variable? Create a new variable, probably put it where? What would you do if you have a new variable? What would you do with it? If you have a new variable, I'd put it where? Let's call it. Does that make sense right there? What did I do right there? What did that code do? What did that code do? So what did that code right there do? Because I have a new variable, so what did I do with it? What did that code do right there? Oh, no worries. No worries. See if Nicole's still here. And good practice, everyone. Good practice right here. What did I just do with that new variable? Where'd it go? And so what did I do with that new variable right there? Well, it was saved to X, and then I took the variable X and stored it to the data frame. And so you could also have options to what you could do. You might need to exclude the other variable from your model. But the idea is you now have a new variable right here. And it might be interesting, rather, to look at the association. And these are codes right here that might come in use for other parts of the project. I have suggested things like this to people. If we go here to X15, let's go to social view, Q23 social view by major recoded. Really? Where's my major recoded? Oh, because I didn't reattach it yet. Comma data equals data. And pretty interesting right there. And that's because of the new levels I proposed right there. So I'd be interested to see the frequency in these groups. But these are all the new levels right here. You can see some of them have very few, but it grouped together like-minded individuals. I wonder about new 20. Look at that. All these majors right here. Wow. What is new 1? What is new 1 composed of? What is the new 1? So let me go here and go aggregate and do... Can we go... I want to aggregate major by major recoded and do a table. Is that going to work? No. Data equals. Oh my gosh, I forgot data equals. Okay. One equals major coded. Okay. Oh, it's too much. Too much. It's not what I wanted, though. I think I did it reverse. I want to look at... Oh, because it's so many majors, it's going to be huge. Let me start as a data frame real quick. I don't think it's going to start properly, though. Let me reverse it, because that might look better. There's the majors. Interesting. Can we work on... Yeah, we did that one earlier. Good question right there. We did that one just earlier right here. That was the last one we did. That is right here. So check it out. Good question right there, Julia. At the 38-minute mark right there. Check it out. Let me know if you have questions. 38:43, the Core Plus Mathematics right there. Good question, Julia. And so pretty interesting. These are all the... Are those the conservative one? This new 1, right? So new 1 is the conservative, and new 20 is the more moderate liberal. New 20. So new 20 right here has what majors? Child and family studies, biology, recreation sports management. But those all have such little variation in it. Frankly, the variable also needs to be recoded because you have a lot of misspellings. So a lot of recoding right there. So this is a very, very messy data set. What else are people wondering about this? This is dealing with a really messy variable right here, kind of reworking the levels to get some sort of cohesion between it, to get like-minded individuals together with the proposed levels. Especially if we have a, let me try to do it on the, let me try a quantitative variable because I bet you it will work. Let's try it on the quantitative. Let's not do social views here. Let's do Q03. And it does work. Yeah. So this, there we go. And now we should see right here. And whoa, so cool. I'll watch that one. The question has confidence. Oh, sure. Let's do the new one then. Let's do the new one. So there's a different one. Let's do it. Okay. So you can use a quantitative variable in the proposals. Katie and Nicole, how are you doing on this? And then let's go here and ban user. Hide user on this channel. Boom. There we go. Done. So is it working? Is it working, Katie? Is it working? How's it doing? We are doing okay. So you should get something like this right here. Did you get the code working on that? I know there was a bit of an issue. It's not working? Oh, no. You can just remove it if you want, yeah. But you should have this right here, and this is doing what right here? This is proposing levels based on people's age. So I would highly suggest, does it make sense right here, to put your Y variable of interest right here if you have a quantitative Y level it's working. And if we go here to frequency, it's going to work to make the new levels. It's giving us a warning. That's fine. Now the levels are proposed based on frequency right there, which is keeping them what? And actually, it only went to a certain amount of target levels. But now the frequency is about even between the both of them. Okay, bye everyone. And here we'll do Julia's question right here to end off. Let's head back here to the main screen. Whee! Okay. Can't believe we get bots on this channel. Bots must be all over YouTube. If we get bots, then it's like they have to be everywhere. Let's do that last question here, Julia. You got it. It's the question 17 quiz about the CPM and calculating the margin of error. So Julia, good question right here. What is the margin of error of an interval? What is the margin of error of an interval? The margin of error of an interval is what? Think about this. This is the interval, and this is the margin of error. So the margin of error is always what of the interval? So remember, the margin of error is always what of the interval? What is the margin of error? It is always what of the interval? Good review question. Oh, I found the question. So the margin of error is always, well, the difference is the length of the full interval. Like the difference is how far my thumbs are apart from each other. But the margin of error is always what of the interval? The margin of error is always what of the interval? So the margin of error is always what of the interval? The margin of error is always what of the interval? Let's see. The margin of error is always what of the interval? What if I told you I could look at this and I could say the margin of error is about 2.9? How far away, or let's just say 3. It's about 3. It's close to 3. We got to carry some decimals here. How far away is 5 from 11? I wish this did easier versions of these problems so you could understand the concepts. How far away is 5 from 11? Like 5 from 11 is how far away? How far away is 5 from 11? 6. So at the center of this interval would be 8. And you could say that this interval is 8 plus or minus what? That's the margin of error, which is half the length of the interval. You could say that this margin of error is 8 plus or minus. So the margin of error is the plus or minus on the interval. So you could say that this is what? 8 plus or minus what? What would be the margin of error? 3. Yep. So the way to get the margin of error is to do the upper minus the lower, divide by 2. Half the length of the interval is the margin of error. That's a margin of error, and that's a margin of error right there. Half the length of the interval. So we can do upper minus lower, divide by 2. So that's the formula we're right about to use right here. So watch on the screen as we do the same formula, but we're going to carry decimals this time. So 3 is just a guesstimate of it, but we know we're going to be in that ballpark when we get the answer here. So upper, there's the higher value of the interval, minus the lower, divide by 2, and it's that right there. So enter it into 4 decimals. There we go right there. Does that make sense? Half the length of the interval, the upper minus the lower divided by 2, half the length of the interval. Really good questions coming up right here that if they had made a 98% confidence interval, what would happen to the interval? So if you go from a 95 to a 98, your interval will always get water. If you go from 95 to 98, your interval will get water. When I go to 98, the interval will get water. The interval will get water. From 95, there's 95, there's 98, 95, 98, the interval gets water. So when you go like 68, 95, 98, the interval's getting larger, wider. It covers more values because you're more confident. So the margin of error would be larger because the critical value that creates it increases. The critical value they're talking about is this t statistic down here that is used to create the interval. So when you go from a 95 to a 98, the critical value t that creates the interval when we do the equation, we'll show one of the equations right here that we've been solving today. We did some. Here we go. This t statistic right here would get larger if you increase the level of confidence. The t is connected to the percent confident we are when making the confidence interval. Explain what the interval calculated means in context. With 95% confidence, the average, because we're not talking about an individual, we're talking about the average of students using the, okay, so since the interval is positive, which mean was higher? So this is a good thing to know right here. Since the interval is positive, which mean is higher? And the way to think about this, if you're wondering how I would solve this, is if you think about it mathematically, you have two means up here. The mean for CPMC, I don't know why they wrote mu. I guess they might see that somewhere. So which mean is higher? The first mean. Because if you do something like 20 minus 12, what does that solve out to? Like hypothetically, if that was 20 and that was 12, what does that solve out to? 20 minus 12, which is the first, well, what would that solve to? 20 minus 12 solves out to what? Which is towards the center of this interval. It solves out to 8, which is towards the center of the interval. But what if we had the reverse? If it was 12 minus 20? Now the difference would be what? And I think you're seeing it, Julia. So if it was 12 minus 20, the difference would be what? Which would suggest the second mean is larger because the difference is negative. So now if it was 12 minus 20, the difference would be what? It'd be negative 8. And that would suggest the second mean is larger when the difference is negative. So when it's negative, we have evidence the second mean is larger. Maybe we'll see if we have enough evidence right here. We do have evidence of the first mean being larger. So using the CPMC methods, the scores between this points higher than the students who were taught using the traditional method. Once again, it's higher for the CPMP method because it is a greater mean. Because it's greater than 0, because it's positive, yeah. Does the result suggest that there is a difference? So yes or no? Do these results suggest that there is a difference here? Yes or no? Do the results suggest that there is a difference? I think these students with the CPMP method score between about 5.5 to 11.4 points higher on average. What is not contained in that interval? What is not contained in that interval? Not contained in that, yes, it does, because 0 is not contained. So contains only positive values. 0 is not contained. No, what did we do wrong? What? Don't tell me there's some sort of decimal error on this one. Wait, what? I gotta put in a value. It is? Wait, what? Type an integer or decimal rounded to 4 decimal places as needed. Did I make a typo? Julia, do you see it? I would seriously give you your points back on this. Do you see it? It's the last question we get wrong today. I would, if you got this wrong, just email me. Like, if someone had this, I see it. I see why it's wrong. We're off by 1/10, 100th, thousandths, 10,000ths. We're off by, or technically 500 thousandths. We're off by 500 thousandths. I mean, the degree to which the answer was wrong, there's no leeway on that. I just want you to, I wish you could just put in the 0.05 right there then, but it's going to say like, nope, you didn't round it. So it wanted that last digit rounded up right there, and that was the issue. So, wow. Wow. And that's why I love using software, because on software, you can just go here to prompt.test or something and put in your values and get your interval. Store this as X, and then go to your X. Where's the interval? Confident right there. And there's the lower. So you can go right here and go to that. And there's that. And you just divide that by 2. There we go. And then you could store this as ME. And then you just do round ME to 4 decimals. There you go. Totally different problem, but that's why I prefer using software, because as long as you type the code the right way, you get the right answer. So I know the margin of error on this interval is 0.09991, and you can see it up here that the interval goes from about 40% to, oh, it's not a symmetric interval. So, but a lot quicker to use code for it to solve problems like that, where you get something wrong with this. Drives me crazy. Well, Julia, excellent work. Make sure to carry those decimals. If you get something wrong because that last decimal place, always let me know. Until then, bye for now, everyone. Bye.